All right, so let me go up. Oops, to here. Okay, so now, but dividing it into 52 weeks was pretty arbitrary.
Yeah, you could do it in, depending on how long the event is, or it could vary. You could do it in days, even like hours if you really wanted to.
Yeah, let's do it in days, so 365. Do you think I'm going to get a different answer?
Well, I think yes, you should get a different answer from this. Well, the individual probability per day is going to be less.
Yep, because I've taken care of that, and so frequency divided by divisions. So in order to see the event now, I have to see a number in my random reel that's below 1/365, 1 over 365.
Yep.
But so do you think over the course of a year I'll get a different answer now for how often I expect to see 0 events, 1 event, 2 event, 3 event?
I think for one event it's going to be similar because in this case you're basically dividing the chance that you get the event by 7, but you're multiplying the amount of times you're looking for the event by 7. So I don't think it should be that much different, but I think it'll be different for the other ones.
Okay. Well, let's see. It takes a little longer to run, but we're only doing 10,000, so it doesn't run too long. So what do we see now?
We see actually very similar probabilities to before. We have the almost 37% and 37.26% for 0 and 1, and then again we divide by 2 to go down to 18.4.
Mm-hmm.
To 3 we divide looks like by 3 going to 5.5, and then we see the similar number is 1.68 was close to what we saw before.
Yeah, I'll run it again just to make sure it wasn't just a fluke.
We see more of the same actually. So
yeah.
There's a little variation, but overall the numbers are staying around what they were for.
Yeah, and then this is what, when I did a million runs, actually the first one was for 365 days. So this is what we're seeing here for a million runs to try to get rid of that variation a little bit. So we see 36.82, 36.87. So again, the zeros and ones are pretty close. Then 18.6, 1.5, 0.3. And I guess we could compare that with the million runs where it was divided by 52.
Yeah, they look extremely similar.
Yeah, so it's interesting. It doesn't matter what you divide your numbers, your sort of intervals.
Divide the year up into intervals, it doesn't change the overall result.
Yeah, or if you divided it up into hours. So this is a very important question of, if you have something. In this case, we're looking at something that's infrequent, but it still might happen twice. Or we could think about it like, we're having in the middle of a pandemic still. Like, how often do pandemics happen? Like maybe once every 100 years or once every 30 years? How often might you see 2 in 5 years? It's the same kind of question.
Yeah.
So it's an interesting thing. And then one thing I wanted to ask you, have you ever heard of the number E before?
Yes. Although
right.
I don't. I know it's about like 2.718. But I think it has some relation to logarithms, but
yeah.
I don't know.
Yeah, okay. Well, you've heard about it, and
yeah.
it's about 2.718. So it's interesting if I take, this is 36%, 36%. If I take 1 divided by that, 2.71, 2.71.
So the numbers for 0 and 1 are...
Yeah, so 36% of the time I see 0, 36% of the time I see 1, but those numbers actually, when I take the reciprocal, I seem to be getting a number very close to E. So if something happens once a year, the probability of it not happening at all in a year seems to be very close to 1 over E.
So, yeah, about...
And the probability of it happening exactly once in a year seems to also be very close to 1 over E.
Yeah.
So this is an interesting example, not just of an important question in probability and something that's really important to sort of think through and understand, but also it's a very surprising example of where E shows up
Yeah.
unexpectedly. So anyway, I just wanted to show you this and introduce this question, and maybe next weekend we'll think about it a little bit more, or we'll just see what happens if you expect something to happen twice a year, or what happens if you expect it to happen 10 times a year. Like, what does the distribution look like?
Yeah.
So we'll play around with that next week.
All right.
All right, good job, man.